Hi guys, here's a video going over some of the problems from your 3.4 to 3.5 quiz review. As I said, I am doing some of the problems, not all of the problems, because it gets quite repetitive. So I picked some of the problems that I felt people would struggle with the most. So here we go. So this is exponential equations. So whenever you're solving an exponential equation, you always want to start by isolating the exponential function. So here's my exponential function, circled it. I'm going to start by getting rid of the 5, so I'm going to subtract 5 from both sides. That gives me 3 times 2 to the x minus 7 equals 18. I'm going to divide both sides by 3 because I still want to isolate that exponential function. So I have 2 to the x minus 7 equals 6. Now right now when x is an exponent, there's not much that you can do with it, but I can go ahead and take the log of both sides. And when I do take the log of both sides, that is going to allow me to bring down that exponent. So I'm going to go ahead and combine some steps. I'm going to bring down my exponent while at the same time taking the log of both sides. So I have x minus 7 equals log of 2, or x minus 7 times log of 2 equals log of 6. Now this log of 2 I do not want to distribute. As I've said before, I try to avoid distributing logarithms as much as I can. So instead of distributing, it's being multiplied, so I'm going to undo that by dividing. So I'm going to divide both sides by log of 2. I'm going to take log of 6 divided by log of 2 and put that into my calculator. That gives me approximately 2.5850, and then I'm going to add 7 to both sides, so I get x equals 9.5850. And I'm rounding to 4 decimal places because that's just how I like to round. For the next one, I already have my exponential functions isolated. I actually have 2 exponential functions. So I'm going to go ahead and jump to taking the log of both sides right off the bat. Since I have 2 sets of exponents, I'm going to bring them down at the same time. So I have x log of 3 equals x plus 1 times log of 2. Now that log of 2, again, I don't want to distribute because I try to avoid distributing logarithms. So instead, I'm going to divide both sides by log of 2. Now, log of 3 divided by log of 2 is just some number, which I am plugging into the calculator right now. And that gives me 1.5850 equals x plus 1. Oh, I forgot my x. Let me fix that. So 1.5850x equals x plus 1. Now I want to get my x's on the same side, so I'm going to go ahead and subtract this x over here. Don't forget, if there is no number in front of your x, it's like having a 1 there. So I have 1.5850x minus 1x gives me 0.5850. X equals 1. And then I want to solve for x, so I'm going to go ahead and divide. Let's plug that in the calculator. So 1 divided by 0.5850 gives me about 1.7094. Alright, I'm going to go ahead and do the same thing for the next question. Now I chose to do 2 of these even though they are the same type of problem, just because every year people forget how to do them. I'm going to bring down my exponent at the same time as taking the log of both sides. I'm going to divide by log of 4 because that would be the one that I would have to distribute since it is sitting next to that parenthesis. I'm going to take log of 6 divided by log of 4. I'm going to plug that into my calculator. And that gives me 1.2923 times x. And then of course I want to get my x's on the same side, so I'm going to add x to both sides. Keep in mind, if there is no number, it's like having a 1 there. And that gives me 5 equals 2.2923x. And then I want to divide. So I get x equals, I gotta plug that in, 2.2923, approximately 2.1812. And again, I'm rounding to 4 decimal places just because I want to. I actually think on my answer key I rounded to 3 decimal places instead of 4, my other answer key. All right, logarithmic equations. So logarithmic equations, you always want to start by condensing if you have 2 separate logarithms. So over here I am adding my 2 logarithms, so when I condense them, I'm going to condense them with multiplication. So I'm going to take 3x times 2, that gives me 6x, equals log of 2x minus 8. And then I'm going to look at the type of equation that I have. So in this case I have log equals log. Well, when I have 2 logs of the same bases on both sides, I can go ahead and cross them off and set what is inside my logarithm equal to each other. From here, I want to get my x's on the same side, so I'm going to subtract 2x from both sides. That leaves me with 4x equals negative 8, divide by 4, and I get x equals negative 2. Now, before you box that as your answer, with logarithmic equations, you gotta double check it, because inside my logarithm can never be negative. So that is 3 times x. So if I take negative 2 and plug that in there, 3 times negative 2 is negative 6, which does not work. So this one actually has no solution because you cannot have negative values inside your logarithm. For the second one, since I am subtracting, that is division when I'm condensing logarithms. Division you can write as a fraction. So I have x over x plus 2 equals 3. Now, if you ever forget whether you're going to multiply or divide, you can look at your subtraction. The subtraction symbol looks like a fraction bar, right? They're both lines, so that means you're going to use a fraction bar. Now, natural log is the same thing as a log base e. So what I want to do, since I have log equals a number, I want to change that to exponential form. So I have e to the third equals x over x plus 2. Now, e to the third, I'm going to go ahead and put into the calculator to figure out what that is as a decimal, and that is approximately 20.085. I'm going to, well, okay, I'll just do 4 decimal places since I did my other one with 4 decimal places. Might as well stay consistent. Equals x over x plus 2, and then I'm going to cross multiply. So I have 20.0855 times x plus 2 equals x. Gonna distribute, so 20.0855x plus, oh geez, I shouldn't have done so many decimal places. 40.171 equals x. I'm going to subtract so that I can get my variables on the same side. Well, this just looks ridiculous with all of these decimals. That's okay. So I get 40.171 equals, again, if there's no number in front of your x, it's like having a 1 there, so I'm going to do 1 minus 20.0855, which gives me negative 19.0855 times x. And then I'm going to divide, and I get x equals, oh boy, I shouldn't have written so big. 40.171 divided by negative 19.0855 gives me approximately negative 2.105. Now again, inside your logarithm cannot be negative. So that right there tells me that x can't be negative. So this one has no solution also. All of that work and there was no solution. That's too bad. But you would never know until you got to the very end that there would be no solution. All right, I think I have a couple more logarithmic equations for you. Okay, so if I look at the first one, I am adding. So what do I do with addition? I multiply. So I'm going to take what is inside my logarithms and multiply them together. So I have log of x times x is x squared. X times -3 is -3x equals 1. Now if I look at this, I have log equals a number. That means I need to change it to exponential form. So my base, if there is no base, is a 10. And then I'm going to swing. So 10 to the first equals x squared minus 3x. Well, 10 to the first is just 10, and since I have an x squared, it's a quadratic, I want to get it equal to 0, so I'm going to subtract 10 from both sides. And hopefully this is factorable, because I really don't want to do the quadratic formula. So two numbers that multiply to -10 and add to -3, -5, and +2. Perfect, no quadratic formula. So I have x equals 5 for the first one, and x equals -2 for the second one. And again, inside your logarithm cannot be negative, which means that -2 does not work. So my only answer is the x equals 5. And for this one, again, I am adding, so I'm going to go ahead and condense my logarithms with multiplication. So log base 3 of x times x is x squared. X times 2 is 2x equals log base 3 of 8. And this one is log equals a log, which means I can go ahead and cross off my logarithms and focus what's inside my logarithms. Focus on what's inside my logarithms. And of course, another quadratic. Let's get it equal to 0. Keep your x squared positive. That way it's easier to factor. I'm going to subtract 8 from both sides. And we factor. Hopefully. Two numbers that multiply to -8 and add to 2. -4, +2. So I get x equals 4 and x equals -2. But of course, inside your logarithm can't be negative, which means -2 does not work. So I just get x equals 4. Alright, so that covers your questions from section 3.4. The rest of your quiz is from 3.5, which is word problems. I should say which are word problems. That's more grammatically correct. Okay, so you deposit money into an account that pays 2.35% interest compounded continuously. How long will it take that money to double? So all I have is the fact that it is compounded continuously, which means I'm going to use PERT. So A equals P e to the RT. And I want to know how long it's going to take for that money to double. Well, I didn't actually give you an initial amount, so I am going to make it up. Let's say my initial amount is $500. I want to figure out the time it's going to take for that to double, so that means my final amount is 2 times that, so 1,000. I'm going to go ahead and use those values to set up my formula. So 1,000 equals 500 e to the RT, so R is 2.35%, which is 0.0235 as a decimal, times t. And then, of course, to solve for t, we're going to isolate your exponential function, so I'm going to divide both sides by 500. And that gives me 2 equals e to the 0.0235t. And then since I'm solving for this exponent, I need to bring it down somehow, and the only way to bring it down is to incorporate logarithms. I am choosing to do a natural log because natural log of e equals 1. So that part equals 1, so it disappears, because 1 times itself is just itself. If you're wondering what I'm doing right now, I'm dividing. I lost my train of thought. So I'm dividing both sides by 0.0235, and then I'm going to plug it into my calculator. So natural log of 2 divided by 0.0235 gives me about 29.5 years. Your unit is always years when you're dealing with continuously compounded interest formula. So it takes about 29.5 years for your $500 to turn into $1,000. That is a long time, but it's free money, so you just earned a free $500. All right, let's do some more. The population P in millions, I'm going to highlight that piece, in millions, of Italy can be approximated by this model, where T equals 0 corresponds to 2,000. What is the population in 2005? Well, T equals 0 corresponds to 2,000, so that means T equals 5 corresponds to 2005. So I'm going to go ahead and plug in 5 for T. So I have 57.563 e to the 0.0052 times 5. I'm going to plug that into my calculator. Plugging it in. That gives me 59.08, and your population is in millions. So 59.08 million, that is your population in 2005. All right. In what year does the population reach 61,428,000 people? So initially I highlighted the phrase in millions because your formula is condensed, meaning that you will not see the entire number when we're talking about it in terms of millions. So this right here, that 59.08, actually represents 59 million, whoops, that should be an 8. 59,080,000. Okay, so I want to change my number for part B in terms of a decimal that represents millions. The easiest way to do that is to look for that comma and the millions marker and just change that to a decimal. So now the number I'm working with is 61.428 million, and I do not need those other zeros since I am condensing that number. But I'm writing down the rest of my formula, and I want to solve for time. And then just like with the other one, isolate my exponential. So I'm going to divide. I'm going to plug that into my calculator. 61.428 divided by 57.563 is approximately 1.067 e to the 0.0052t. Natural log both sides. I'm going to bring down my exponent at the same time to combine some steps. And of course, natural log of e equals 1. Adios, natural log of e. And then I'm going to divide by 0.0052. 0.0052. And my time is approximately, let me plug it into the calculator. Divided by 0.0052. That gives me about 12.5 years. Okay. Now, before I box that as my answer, I want to make sure I'm actually answering my question. So my question says, in what year does the population reach that amount? It doesn't ask us how long it takes, it asks us for the year. So t equals 0 corresponds to 2,000. So if t equals 12.5 years, then the year in which this population, the population reaches that amount is 2012. All right, last one, half-life. So a certain radioactive substance decays according to this formula. I'm going to go ahead and circle it. Where Q0 is the initial amount of the substance, T is the time in days. What is the half-life of the substance? So once again, I do not give you enough information. So when that is the case, we are going to make it up. So you can pick whatever value you want for your initial amount. I'm going to go with 30. Okay, so since I am looking at my initial amount being 30, I want to figure out how long it takes for it to reach half of that amount, which is 15. So I'm going to set my equation equal to 15. And then I'm going to write the rest. So negative 0.00123t. Again, isolate. So I'm going to divide both sides by 30. That gives me 0.5 e to the negative 0.00123t. And then I'm going to natural log. I'm going to bring down my exponent at the same time. Natural log of e, which we know is 1. So there that goes. And I'm going to divide. So as you can see with these word problems, they're structured very similarly, where essentially you're doing the same process, just in the different contexts. So natural log of 0.5 divided by negative 0.00123 is approximately 564 days. I'm rounding to the nearest day. And your time is in days because that is what the problem tells us. All right, so that concludes your video going over some of the problems from your 3.4 to 3.5 quiz review. Good luck on your quiz.